Dominguez. I'm a dev lead on this current project, the CQRS Journey project.
And we're going to talk about our team's journey into this land of CQRS. I just want to set your expectations straight that this is not something that is typical of what patterns and practices have done. We're not going to talk about reusable components. We're not going to talk about frameworks. We're not going to talk about prescriptive guidance. This is going to be more like a case study, an ongoing case study, because the project is still in flight, of a specific team going through this experience of implementing the system using CQRS approaches on a specific domain, on a specific project. So on that note, since CQRS is something that is probably creating lots of hype, but there are lots of people who either misunderstand what it is or don't even know what it is. What we're going to do is we want to make sure that everybody is familiar with the key terms, and we'll give you that overview briefly. One of the things that I want to mention here is that CQRS is a kind of the space where there's a lot of confusion. Some people treat it as a pattern, then there are lengthy discussions in the discussion list, so no, it's not a pattern.
Yeah, it's an approach. It's
approach, not an approach.
And they are very conflicting way of viewing at this area.
So. Yes, and then some people, make a claim, and we also believe CQRS is not a framework by no means. At the same time, there are some frameworks that have CQRS in their titles. So and even till lately, the search engines, when you were doing a search through Bing, Google would actually think that you were talking about cars and not CQRS. What is CQRS exactly?
Yeah, so in very simple terms, CQRS just means separate your reads from your write. So CQRS stands for Command Query Responsibility Segregation, which it's very simple as that. You have some command that change the state of your system, but do not return any value. And you have queries that just return values but do not change the state of the system. It's a very simple approach.
So this seems to be reminiscent of the Bertrand Mayer's CQS approach or concept from quite a few years ago from the object-oriented programming world?
Yeah, correct. So you're talking about the CQS pattern, which stands for Command and Query Separation. It's a very similar concept. In fact, it's the same, but taking it to the next level. So when Bertrand Mayer first coined that term, he actually meant that in your objects, in your classes, you have methods that some change the state and some query the state. But it was actually talking about at the object level. So this is taking it a little bit further and saying, okay, instead of talking in the same object, you talk about different interfaces or different services or different endpoints altogether. So you have an endpoint for reading and an endpoint for writing. Just as simple as that.
I see. So very well. Then let's take a look at how you maybe actually implementing the CQRS system.
Yeah. Okay. So let's go to a very, very basic diagram of the minimalistic thing that you could do in order to call your system CQRS. So in a nutshell, in order to call it CQRS, you have an endpoint or a stack that you can see on the left side of the slide that is for the commanding infrastructure. That's where your write model is, as opposed to the read model. So you have a full stack for making changes to the system and a completely different model altogether for your writes. So all your queries go to the read model, but they do not have any burden on validation.
You don't have to go through all the same layers and the thing that you have on the
definitely. So if you want to put it in much more concrete terms, if you're using an ORM like in Hibernate, Entity Framework, and so on, you would have conceptually different data models. So it could go to the same underlying data, but some
the data models are conceptually different.
The data models are different, so you don't have to deal with lazy loading and so on, because you have models that are tailored to the specific need that you are actually achieving.
Okay. So we've separated our queries now, so we can take this further with data, can't we?
Yeah. So that was the minimalistic approach. This enables you, now that you're talking about different models altogether, you could be going a little further and you actually segregate the data itself, not just the model. So this is not required for CQRS, but it's something that people actually get into this approach because of this feasibility. So that could mean that you either replicate the data that you have on your write model for your reads, or you transform it, you do some OLAP processing, you do some polling of the data, you transform it, you massage it, you put it into blobs and whatnot. But the point is that you can do transformation and you can look at the data as two different things. So if you are looking into CQRS because of its scalability capabilities, it's typically that you have an application that does far more reads than it actually does writes. It's typically that it's orders of magnitude different. So you have screens that constantly show data, but you actually act on the data less frequent than reading. So if you have
there's, like in an Amazon scenario, there's way more people doing the searches for the items than the people who are actually placing orders.
Yes.
Yeah, so you would do the searches, the orders of magnitude
right.
more.
And for example, getting into what items a particular custom bought when they bought this one, those could be very expensive queries if you think about in a normalized database and so on.
Which would require expensive joins, which would require potentially distributed joins and so on, right?
Yes. So looking at the problem in this way, you can think about scaling the write model from the read model completely separately. So now it's not like you have to replicate the same database multiple times, but you just replicate your reads. So you can still keep the performance and have your data in a single database or not, but that's completely isolated from your reads.
And if you do keep it in a separate database and then you want to scale your read model, then you can achieve a extremely high scalability.
Right. Yeah. So you deal with those problems completely separately, and that fits very nicely because you can deal with having a system that it's completely consistent on the write model, but then have a system that just gets replicated, maybe lagging a little bit behind or not, but in a completely different problem altogether.
I see. So that's plain CQRS. If we look at the accompanying concept that is often mentioned, and people use it often, and people mix the event sourcing with CQRS frequently or use them interchangeably. Let's give a very, very straightforward, clean explanation of what event sourcing is all about.
Yeah, so keep in mind that people usually say CQRS when they actually bundle also this concept together, event sourcing together, which explained in simple terms and separately from CQRS. It's just what we're seeing in the slide. So contrasting it to a traditional model or the relational model or even a document database or so on, you have entities that represent the current state of the system, right? That's the traditional model.
Yeah.
So you could have a cart with all the items in that cart.
And if you change it, then the state underneath changes, and that's
right.
What would
you add an
reflect.
item, then you modify the state.
In the database somewhere, your row will change accordingly.
Right.
Okay.
Right. In the event source approach, you never modify data. You just add new events to the system. So you get an event that says this card was created, then you get an event that you added a few items, then you removed a few items, then you added the shipping information. You append all the information all the time.
So you preserve the whole stream of what had happened in your event stream.
Yes, you try not to lose information. So this information is very valuable to the domain itself. It doesn't focus on having a normalized version of that data. You just have all the things that happen to the system in order to go and see how many items you have in each of the cards. Then you have to replay all that history for each of the cards. So,
which could be viewed as a downside, but
right. So that's typically a disadvantage of that approach by itself because it's very hard to query. It's very expensive.
But there are means of dealing with the long streams, and we're not going to get into that now. But the important thing to emphasize here is that while in the relational model you're focused on what's my data is, what my current data is, with the event source approach, you are actually capturing the intent of why was the data there, what was the intention of the user as those commands have been executed and certain events have been captured in the event stream.
Yes.
Correct?
Yeah. So in the current version that you deploy in production, you might not care that an item was removed or that something happened to the system. You just care about the order or the card at one point in time, and that's it. But in the future, you might want to actually, okay, what happened? Several customers removed this item because they added this other item. Maybe I can mine that information and actually
get some business intelligence out of my data stream there too.
Exactly.
It's like you don't know what you need for tomorrow. So very often the businesses, again, not that they're stupid, they're not. It's just their current needs may only be this much. And then as the system has been put in production, as you're ready for the next version, then a whole bunch of additional requirements come up. And then you think, oh, I wish I preserved that data. Because again, the system is already out there, right? You're already live, you already have customers, you already have real entries. So with the event streams, so nothing is getting lost. And again, this is something similar to the approach in the past, even in the traditional model where people were preserving the intent through journaling, and you could specifically model your historical and temporal data in the relational databases too,
Definitely.
but you have to go through a separate effort, and it's not trivial often, right?
Yes. So going to fast forward to the bundled concepts together, you can see this approach being fitting very nicely together, the CQRS and the event sourcing, because if you have your right model been storing all the events that happen in your system and growing those same events that you're storing for your entities and publishing them into a service bus, for example, then you could have some other components grabbing those events and generating the normalized versions of your entities or caches that are very, very fast and very, very easy to query. So you take the disadvantage of event sourcing not being queryable by grabbing those same events and generating things that are extremely fast to query, like much more than in traditional systems. You can have databases, you can have logs, you can have completely different technologies, and using them all together depending on what's your need. So if you have an app that needs to do some JSON requests, you could store the data in JSON specifically tailored for that view in particular.
So you fit your data and you fit the ways of you dealing with the data to purpose of your subcomponent or subsystem or the bounded context in terms of GDB.
Yeah, so basically you denormalize all that data, and that means that you might have duplicate data.
Which is okay.
Which is probably fine, especially in cloud solutions. The storage of the data is typically very, very cheap compared to when you have scalability needs and so on. So your views will be very fast. They will just get the data. They will not need to do any joins or complex queries to get that data. That's the very important concept there.
All right. So on that note, we probably can realize that if you're doing that and you're splitting and you deal with the projections of data, you're going to end up with the stale data, won't you?
Yeah, so if you look at the diagram closely, there's a point that the data needs to go from the write model to the read model. That could happen synchronously, but of course you will actually, instead of making a system more scalable or even if you don't care about the scalability, but you will slow the system if you do that synchronously.
So the typical way is to do it asynchronously, and it's not going to be instantaneous. And
so that's the typical approach. So as you can see, you have on the left side a queue that it's typically there. It grabs events coming from the write model and it transforms it. That queue can be processed a couple of seconds later than the actual data was written into the write model, or even minutes, or just milliseconds. The fact is that it's stale for a few seconds. It's eventually consistent. It's not inconsistent. It's not like the data is incorrect. It will eventually follow through and get all the events from the write model and actually model that information into a read model, into a fast access cache, and so on. But you have to acknowledge there is staleness in the read model. But and that's sometimes a scary thing to do. Us as developers always want to deal with, okay, this data needs to be consistent to the millisecond the whole time. But the fact is that in real life, you just, for example, looking into a website. You do an HTTP request into a website, you grab the data, it comes to the client, the client looks at the data for a couple of seconds, then it acts on the data and try to save that information. So you can see that the data is stale the moment that you actually try to save. And also what we typically do in classic architectures is that we grab an entity from the database using an ORM and so on. We try to update
modify it and then push it down.
Right, we modify that same data and we try to save it. And at that point, when we save it, we can realize, okay, there was somebody who changed my data. What do I do now? I need to be smart and try to do something at the infrastructure level.
So you then need to deal with all the issues of concurrency, whatever, optimistic, pessimistic, and other concurrencies. And in case of the CQRS and and event sourcing, then you don't have to burden yourself with that.
Well, it's not that you don't burden. You just acknowledge that there is tailings.
Oh, and then you explicitly deal with it at the level of your domain model.
Right. So a command coming from the user, it's not that we grab a DTO from the read model and then try to update it and show it back into our database. We actually send a command that is representative of what we are trying to do, like add an item. We don't say, okay, this is my card, and now this is my card with an item already added to it.
You're just saying add item X.
Right.
Yes. So the other important thing to mention here is that the right model is your source of truth.
Right. The right model is consistent the whole time.
It's consistent with itself.
Yes, it's consistent with itself. It's just that the read model lags a little behind. But that's typically, as we mentioned, not an issue, and you can deal with that at the command level. So you get a command that almost in several cases you can make it succeed because it doesn't matter that somebody modified the data. You are not trying to store a DTO that came from a modified DTO, right?
All right. So looks like there's some questions starting to come in. So as I'm going to talk about the journey, maybe you can briefly scan through those questions and see if we can bring them up right away, or if we can wait till the end of our presentation to answer those questions. And again, for people who do not realize that yet, this is the hashtag you can use to ask your questions in real time. So as I mentioned at the beginning of the talk, this project is a learning journey. The primary focus is on learning. This is the experience that our team is going through. Very much not like anything else at the PNP we've done before, at least my team has done before. We're not building a framework, that's for sure. We're not building application blocks, we're not building components. We're not even trying to come out with the prescriptive guidance, but we want to make sure that we give you enough of the captured experience so that by reading that, you can actually accelerate your learning and see, okay, here's one case, way. Here's one journey through this experience of building a more or less realistic. We wanted it to be complex enough so that it would secure using advanced patterns like CQRS and event sourcing. But at the same time, we wanted the domain to be simple enough for you to comprehend quickly without being necessarily a domain expert.
Right, and this is a case study, but at the same time, we are validating with thought leaders on CQRS and trying to discuss if this implementation makes sense or not, and putting all that in written guidance. So if you read at in the docs, you don't have the finished solution. You get all the decisions that we made, we balance everything and we write it in guidance.
So don't just expect, I mean, of course you can go and download the final version once we're done, but I think the more valuable would be for you to actually go and look through the check-ins, through the evolution of our system and the corresponding comments, so the corresponding discussions for each pull request, and the most important items, the most important learnings would actually be extracted into the book that we're writing. So when you said that we're validating it with the thought leaders in the community and members of the community who are actually experiencing building systems in CQRS way. We have a very, very active and prominent advisory. I think this is probably the largest advisory ever. There's like 70 plus something members, and some of the discussions end up going into hundreds of messages. So the other objective, let me quickly mention here, is that we want to play the role of a catalyst or a facilitator and bring to light all inconsistencies that we see, all issues with the terms or with the way things are presented, and try to figure out what should be the way of explaining them, or point it to the members of the community and gather their opinion, build some of the consensus in the community, so that terminology mess can be sorted out somewhat. And the last objective for our project is actually to leverage the Windows Azure platform and its elasticity capabilities, because as the other cases and testimonials of other members of the advisory have indicated, CQRS together with the ES is something that is prime and that is fitting very nicely into the cloud deployment model, and allows you to deal with all kinds of issues like scalability and big data, etc., quite efficiently. So on the right side, what you see is a schematic of our Pirates journey map here. And you see the various stops as we go through this journey. You see our path in red, and frankly, we've got some of the winding around.
Yeah, there's missing a few loops.
There are a few loops missing as well, and roadblocks. And again, this is the value of the journey, because we don't hide anything. We actually end up publishing pretty much all of our interim artifacts. So you will see for some of the implementations, in this case BC is the bounded context or the subsystems, for people not familiar with DDD, that actually have taken a few refactorings, and we may have implemented them in one way, then later on we looked at that implementation, analyzed it, and realized that it's better to do it in some other way. The other thing, we already mentioned it, but I want to emphasize this again, is that we are trying to simulate the real world as much as possible. So we will have this pseudo production release from which we'll leave the website published, and we will populate. There will be some real data in there, and later on we'll need to deal with additional requirements and evolve the system, add additional subsystems, or modify the behavior of the existing ones, just the way you have to do in the real world. And we'll verify the claim that the CQRS helps you deal with the software revolution in a much more straightforward and easier way. Because again, right now there seems to be a lot of anecdotes, a lot of stories. Most of the code and sample projects that have been published online are very trivial, very primitive kind of toy examples. So hopefully with what we are doing, it will be a little bit meatier for you to truly see what's going on. So just to give you a little bit more context in terms of the current moving parts, in terms of what we've got in our system. The system is the conference management system, so you have attendees, they want to register for different conferences. You also have multiple tenants who are representative of businesses or business customers who want to have the corresponding systems, very similar to what you guys have used in order to register for the PNP Symposium today. So underneath we have the conference management, and actually one of the things that I would like you to pay attention to is that you see that there is a number of various subsystems here, but each of them seem to be implemented in its own way. So we do not have this kind of a broad brush and strokes through the entire system saying, okay, we made a decision, we're going CQRS and that's it. We evaluate, we look at what the system is supposed to do, we ask a whole bunch of questions, discuss it with the domain experts, and then we conclude that for this type of subsystem, two-tier CRUD may be, just as appropriate. So then, in this whole notion of optimizing the amount of work that doesn't need to be done, perhaps that's something that is just quite well fitting for the conference management portal.
Yeah. So Grigori, what he's trying to say is that CQRS is not a top-level architecture, and each of the subdomains should be thought of
evaluated separately.
Yeah,
exactly. On the other hand, when we look at the more comprehensive piece where we deal with the orders and registrations, and that is a truly collaborative domain, you do have a competition there. You do have things that expire. You do have things that may not get fully completed. So there we see that we've implemented with CQRS. Actually, we started it as a CQRS, and later on we came to a conclusion that we wanted to refactor it and to use the event sourcing along the way as well. And we'll talk about the reasons in the lessons learned part of this talk as well. Then we have the discounts. We haven't gotten to implement it yet. We don't know. We want it to be CQRS. We don't know whether it's going to be a CQRS plain or event sourcing.
And it won't make it to the version 1.
And it won't make it to the version 1, correct. By the way, the green arrows here effectively indicate the data flows between the various subsystems here. You see an app, which is the on-site management app below here. And this is actually something that a remote team is working on fairly autonomously, and that will deal with the occasionally disconnected scenario, which actually presents a whole bunch of interesting challenges as well, especially when you think of getting your updates to the right model. So the payment system is another piece. This is where we integrate. You can envision this as being your PayPal or any other kind of a credit clearing house, credit card clearing house. And on top of it, we even throw in a piece which is actually a legacy subsystem, and somehow we need to integrate it into the gist of things later on. We haven't even started that work yet. But again, I just want to remind you, we've only been through the first 4 sprints, and we have a few more to go. So, well, just to show you where we stand, and that was just to give you the background in terms of the underlying moving pieces. I'll show you one basic part, the registration scenario, which is again very primitive for now because we were just started working on this.
Yeah, so this is very raw. We started integrating the UX just yesterday, so as you can see, it doesn't look completely finished.
Yeah,
but
and again, in this case, you see an epic. We're modeling it, and we want to make sure that it's an end-to-end, nicely implemented epic with all the underlying challenges of a customer going and trying to register for an event. And then they go ahead and then they can pick the different session types, there's different costs, etc. And then you go ahead and when you're ready to complete your registration, you see that at this point a temporary reservation has been made, and therefore you get the clock, the expiration clock started. And then you can go ahead and provide your information and click on proceed, and you will be redirected to the payment system and so on and so forth. But there's a lot. It seems to be very simple, but underneath there are lots and lots of things that are happening.
Yeah, so there are definitely different partitions of the system. So this is interacting with the ordering aggregates or interacting with the seats availability, so that's a separate component. So there are a few interactions that we actually wanted to model and have separate, so we can evolve later the system on adding discounts, adding waitlisting, adding group registrations, and so on, in a way that still works with the underlying data. So when we release this to production, we don't want to drop everything and or update the database in a way that it's very, very complex. We just want to have very little autonomous pieces that they can collaborate with each other.
Yeah. Again, the important part of this project is actually how we think about the domain and how we decompose the domain and then deal with all that individual piece separately. And actually one of the things I want to briefly mention, if you go and check out our code repo on GitHub, you would actually see that the scenario that I showed you here, that we started the integration and put in the UX level, if you were to go to our repository, you would see the other scenarios modeled the same way and formulated in the format of spec flow features, or acceptance tests. And for the members of community who are interested in participating and collaborating with us, you may actually want to go ahead and pick. Well, first of all, you can go and check out the registration epic and see what's there. And the same token, you can go and check out the conference epic. That's the conference management part, and then see all these features and potentially even go and provide your own implementation and submit, and then we'll try to see how easy it is to actually integrate with our system. Yeah. So moving on, we just got to the slide where we kind of captured the 5 most important, I don't want to call them learnings, I think they're more realizations or discoveries.
Yeah.
We've gathered with our team yesterday, and we said, okay, what would be the top 5 that we would call out as highlights so far?
Right, yeah, so the first one is something that is
That's
said,
a biggie.
Yeah, so it's absolutely the biggest one, and it's said by the consultants or the people that actually are talking about this pattern, but we actually experience that it's a big paradigm shift. It's you have to think about how you model the data and how you partition the system and how you model the domain actually in a completely different way that we are used to when we have the classical relational models and we have a big database with tons of tables that actually requires a lot of work, but it's a different kind of work. So the modeling aspect of this is very, very important. Actually, the partitioning aspect is very important. Some approaches like DDD, domain-driven design, helps
or some
you,
other type of modeling that you may be accustomed to.
Definitely. You don't have to do DDD, but it definitely helps. You need some methodology or some approach that you just use methodically and partition the data, which is something that it's not simple. So we could have done the same version that like the B1 that we are going to release very soon. We could have done it with the same amount of features in the
much
classical
faster.
sense, much faster. So we are very used to, we are advanced developers in a sense, so our team is full of advanced developers, but this requires a lot of unlearning and relearning of some concepts.
Well, so look at it this way: we could have done it much faster for V1, but then we don't know what would the effort be if we wanted to go and deal with the requirements volatility, with the uncertainty, with all these new things that may be thrown our way, in terms of the system evolution. Again, the biggie thing, one of the benefits, and we don't consider scalability to be something that is, the primary win when you start using CQRS. The big thing here is that you end up decomposing and simplifying and thinking about your domain and implementing it in the ways that will make it easier for you in the longer term to maintain, to deal with exactly the same issues that we just mentioned. So we don't know if it's actually true or not. We suspect it is. Again, there are lots of people in our advisory who have experienced that, and we have all reasons to trust them. But again, since this project is experiential in its essence, till we actually get to see that, here we've got a team of senior developers going through this, unlearning and building it in the new way, hopefully with all the validation by our domain experts or the CQRS experts in the on the calls and in the advisory. But then as we start working on V2, are we going to reap those benefits or not?
Yes. So we are starting to gain more and more traction with this, but definitely count on there's a tax for the learning. So the first project, if it's a small project, it would be hard to find the balance on when you start to actually gain the advantage. So you might get the advantage because you know a new pattern that you can use in your toolbox, but definitely plan that there is some tax when you're learning this.
Yeah, so don't assume that it's going to be quick and easy, as some people may want to portray it. It's not.
The concepts are simple.
The concepts are simple, but then changing your mindset to apply them in that way systematically and methodically is something that's not easy.
It might be easier if you come from a DDE background or some other means of distributed working with your data, but plan on this learning.
Yeah, I see a question on Twitter here. Jay Keen is asking where he can get or she can get more information on CQRS. At the end of the talk, you'll see the links to our main primary site for the journey, and from there on, you'll be able to actually get references to both our guidance or our journey docs, which will include comprehensive references to a lot of materials and talks and presentations by people like Greg Jan and Udi Dahan and Rinat and Peter Ricci and then the Jonathan Oliver. There's a lot of people who have put their heads to be thinking about this, and we'll definitely have that at the end. So watch for that link. Let's move on to the second learning. Again, this may be a little bit harsh, but when we came to this project and we started our exploration in January, somehow we didn't expect that the space would be that messy. We thought that since the pattern's been around for a while, there are lots of people who are talking about it. The discussion list is super active. I'm talking about the DDD CQRS discussion list, not our advisory list. That by now that there would be that this space would stabilize a little bit, and there would be a little bit clearer stance on many of the concepts, many of the ideas. And as it turned out, it wasn't the case. There is still a lot of confusion, there's lots of inconsistencies, dissonance, and we're hoping that at least with our project here, when we spend several months going through this, learning through all this experience, that we can bring it to light of the thought leaders in the community, and maybe together build some consensus on the key terms. Again, there's the few examples I'll give you is this constant vicious debate on business components versus business contexts, and then there's another one that will
context. Yeah,
bounded context versus business components, etc., etc. It's just it's a nightmare just to go and sort out through this, and it looks like in order to explain the differences, people start inventing new terms, which in our view is not helping people who are just starting in these journeys. So what's our number 3?
Well, we already briefly touched on that, so that CQRS is not a top-level architecture. That's an important one, although at first you start looking into this architecture and you say, okay, this would be helpful almost everywhere. Have in mind that, especially at first, in our experience, you have to pay some of the learning tax, so you can pick and choose each of the subsystems. Now that you partition the system in smaller components, you can actually implement them in different ways. So have in mind, it's not like you decide to go in CQRS and you do it for all parts of the system. You might do it for the parts that need scalability, or for the parts that need a lot of competition for a particular resource, or for a component that just have to deal with constant business rules changing and evolution of that system. So,
okay. So the fourth one is related to the previous few, and again, it may appear cryptic, but basically what this says is that the sagas, at least the way people in the CQRS community have been treating them and using them, are not actually the sagas according to people who have coined the term, almost 3 decades ago in the distributed database community. And this is something, again, that misleads, that confuses, and one of those things that we're hoping, and here we're calling it out very explicitly to make sure that perhaps people will stop mistakenly using the term for what they mean, just to be the workflows or state machines. But the sagas, at the high-level concept for people who are not familiar with them, the idea is to have some mechanism of dealing with the long-lived transactions, or long-lived
distributed transactions.
Distributed transactions going and touching on multiple subsystems and reacting to lots of things, and they're very, very, the concepts are familiar, and they're similar actually in both camps, in both schools. But in the distributed DBMS, they're very, very explicit about what it means to implement a saga. What kind of compensation action you need to have for each atomic operation within a saga? What kind of forward recovery mechanisms you're going to put in place in order for this thing to actually be called a saga? And in most cases, none of those mechanisms are being put in place by people in the CQRS community who call it sagas. And that again confuses those of us who know about sagas from the previous years. So again, make sure that you verify the terms, the definitions, and again, in our case, you will actually see this part of learning, the number 4, you'll see in our code base. For a long time, we had in our code base a piece called Registration Saga. And then it was actually called by one of the advisors very explicitly that this is not what it is. This is not what a saga is supposed to be. And actually, when we went and verified the sources, the original paper by Hector Garcia Molina from Princeton, we've actually recognized that that was a wrong call on our side. And then we went and evolved it, and then it turned into a registration workflow. And later on, we've discovered the pattern from Gregor Hopp's Enterprise Integration Pattern seminal book, a very, very solid volume there, which seems to be fitting into what we're trying to do the best. So now we're calling it the Process Manager, and you'll see a corresponding registration process in our code base. But on the same note, actually, this could all have been avoided if we didn't try to implement a saga right from the very beginning. And perhaps that's probably the word of wisdom if you're just starting into CQRS.
So it looks like a simple topic, but it's really not. So if you can avoid it, at least at first, and you can do the integration and dealing with these distributed transactions in a different way, like have a simple event handler that gets an event from one store and then does a change in some other store, then try to go that route first, because it's not a simple topic. So you wouldn't want to jump right in it in the very beginning.
Very well. Number 5?
Yeah, so one of the things that we had in one of our subsystems, or bounded context, as we call it, the orders and registration bounded context, we used to have a system implemented with CQRS without event sourcing, plain CQRS. But at the same time, we were having to do a lot of integration with other subsystems. Their integration was done by using events. Mm-hmm. So whenever we did a change into in an aggregate, we modified the state into that ORM entity, and at the same time publish an event saying, okay, what changed? Mm-hmm. Because that information was valuable to other subsystems. Yep. So we ended up having entities that had dual responsibility. They were trying to preserve its own consistency in the current state of that entity itself, but at the same time publishing events that, if you were a little stoppy, could get out of sync, or there could be more information in one of the stores and less information in the event.
So it was getting out of hand quickly.
It was getting a little out of hand, and because we had that need to publish a lot of events, we said, okay, let's forget about doing using an ORM and just have the aggregates done with event sourcing altogether. So we grabbed those same events that we used to store and get the state of the aggregate and publish them into the event bus. So the integration is almost for free in a sense, that because you don't have to do more work to get the integration going. You just publish the same events.
So just to reiterate, if you're doing your integration with events, you might as well consider using CQRS ES, that bundled complementary approach altogether.
Yeah. So a question Igor is asking is, what do you do with huge event logs? Trim them, compound them. Also, how to prevent loss on a single compute instance. So
huge event streams, long event streams. I don't know, millions, hundreds of millions of events.
And that is one part of the paradigm shift that we just mentioned. You have to think about how to partition the system in different ways. So you typically do not have a single event stream for all your system.
Right.
You have a lot of event streams. You can the easiest way to partition this event stream is by aggregate. So
one event stream per aggregate.
Right. So for example, you have an order that is updated through time. So that's one partition. So in order to look at what is the current state of your order, you just get all the events for that order, which shouldn't be many.
So and it's not just per aggregate in terms of a specific type. You're talking about per aggregate as per specific instance of a type.
Right, per instance. You can see that you have an event stream per instance in your instance of an entity in your application.
Okay.
Right. So there are some cases that you have when you are coming into this land that you think that you will have tons and tons of events for a single instance, but that's where you have to start thinking, okay, how do I partition? Is something in my domain that makes sense? Like if you have a stock quote that keeps the value of the stock changing all through time, like I have 5 years of history of my stock changing, but you might start to think in the domain, okay, what does it mean for this to be changing? You actually have roll-ups, so at one point in time you close the buying and selling of those stocks, and the next day you just start from that roll-up.
You either close the day or you close the year, depending on your domain. You would have different ways how you do your rolling out.
And you have a different event stream and different partition to get the values from.
Mm-hmm. And since we're getting close to the time here, I want to invite everyone who is watching us today and who will be watching us later on, because the talks are all going to be recorded and published on the Channel 9 sites later on. Please follow us on this journey. The journey is not complete. We just kind of put this teaser for you to tell you where we are. So this far, there's a lot of additional challenges and interesting questions that we still have unanswered. This is our main site. The links to all the corresponding repositories are there, and we look for your participation. Please engage with us. Send your bug reports, send your suggestions for stories, do the doc reviews. We actually have another system that allows you, for people who are not very comfortable with GitHub, there is an easier way for you to review our docs and comment on them in the browser, and you don't need any other tools other than the browser. We are also taking contributions. Trust me, it wasn't easy. In a company like Microsoft, it wasn't easy to get to the point where you get all the legal approvals to have a project where you are doing it totally in the open and you collaborate so closely with the community that you can actually take contributions. So we're welcoming pull requests. If you do not like any of our implementation, if you do not agree with how we may have put together the event source infrastructure underneath, don't just complain about it. Don't just write a blog post. Actually, go and modify it to the way you think it should be done, and submit a pull request. We promise we will review those in due time. So on that note, actually, this is good. I'm looking at the time. We actually have a little bit of time to answer more of the questions. So.
So Aman is asking, what actually does Saga mean? So as we said, this is a concept coming from So
let's give the Saga definition from the people who actually coined it.
Right. So it is actually to deal with distributed transactions when you have a change that actually affects many different distributed stores or database. You might want to have a way for doing distributed transaction that is not locking. So it doesn't need to lock all the resources or do a two-phase commit and actually go one by one and blocking everything, locking, and then commit it in a single point, because that could be very expensive and actually it could be not feasible at all.
True.
So the Saga was invented here, was coined in a way of how to deal with that. So you treat each of the distributed database as and the changes that you do to them as an atomic transaction, and you have all these steps that a Saga must perform, all these atomic transactions, and it actually has to deal with what happens if I already committed a transaction in one of the database and in the next one I fail. So then I need to deal with how do I compensate for that other transaction which was committed. There's no way to abort it. It is committed. So it is very specific on how to compensate and roll back. It's not as simple as rolling back in the traditional transactions. Mm-hmm. You have to compensate for all, or have a way to save the current state of that Saga. So if that process also in the Saga crashes, then it can come back up
and restore from that point on.
And continue with that transaction, or if there's an issue, actually instead of compensating, it can do a forward recovery and continue with some different kind of processing. So it deals with that particular problem. So the sagas in CQRS that we are actually trying to avoid calling them sagas.
We're calling them process.
Call it process manager or
process.
Yeah, but it's definitely not the saga. It is in essence doing a similar thing, because as I told you, you deal with a lot of partitions of the data, but the way it's implemented is typically very different. So that's the whole story about them. So
and again, if you want to learn more about our saga about sagas, do check out the evolution of that particular class registration saga and how it has changed over the time.
Yeah, and look at the documentation. There's a lot of discussion on that topic and why it's different from the CQRS sagas and so on.
There's another question: how do you tell if reads are usable? Will they be need to be stored? Won't duplicate reads slow down computation?
So reads are typically something that you denormalize data. If you are using especially event sourcing, you get all the events and you can try to materialize a read that is fast. So you can see read as a cache. It could be persisted in a store, which is typically the case, or it could even be in memory. It's not mandatory that you store that in a persistent store, but you can definitely do it in memory. But typically, that read store is actually something that it's not the source of truth. If there's a bug, you can fix the bug, or you can evolve the system. You can wipe out your entire read model in some cases, assuming you have all the events that created that view. Replay all the events, and you get another view. Or you can, from the same events, you might have an additional screen, and you can get a different kind of view altogether. So trust and never, of course, wipe out your write model, which is the source of truth. But the read model is typically seen as a cache. It's a persistent cache, but it's typically a cache.
So Noel asks whether not being a top-level architecture, whether that makes the system even more complex with CRUD databases as well as separate reads, writes databases. No, it doesn't. Actually, because and we can attest to that through our own experience, where we've tried to shoehorn something into the style of the architecture that we had selected a priori, and it wasn't very well fitting. So in case of our subdomain, which is the conference management portal, this is not a collaborative domain. We don't foresee lots of contention. This is like a business customer going and creating his own conference. And this, if you think about it, it is very much just like the old days data entry applications where you just go and modify some of the parameters, submit, and there you have it. There's your update. Yeah, so from that perspective, building that as a two-tier CRUD was actually the simplest thing that we could possibly have done.
Yeah, we spent some time on the registration and the order in bounded context, but the conference management, which has spent, I think, 2 days, and we got that working. That is doing some integration through eventing, which adds a little burden on top of it, but the system by itself, the subdomain by itself, is really easy to implement and have something working even with some scaffolding and so on, and it just works.
But again, generally speaking, the style of architecture that you're adopting should not be mandated or should not be just inherited because, you know, everybody has done so for some time. You actually, the best thing you can learn from our experience here is that you go and you evaluate the business domain that you're dealing with, and based on the needs of that domain, you fit the you find or select the architecture style that fits to that purpose the best. So the other example there was when we were dealing with the registration subdomain, and we realized that we wanted it to be plain CQRS. Just plain CQRS. This was something that we said, well, in the guidance, we want to have the mix, CQRS and ES. We wanted to have CRUD, but we also wanted to have plain CQRS. And as we were going through that, we quickly realized that we were going through all these contortions that we you know, would have done much easier if we set out to do with the CQRS and event sourcing right from the very beginning.
Yeah.
Yeah.
There was another question before that, some while ago. Miguel Lopez was asking something like, how would you create a system where you have reviews and comments, similar to what Amazon does with CQRS? Well, you typically will have the reviewing and commenting part or the subdomain in a completely isolated place, separate from the product itself that you are selling. So you could add new reviews and so on, but it doesn't affect the product itself. It's accessed the way when you're querying the data to get the most popular products and so on. So you actually end up modifying two different systems that they end up smashing that data in a read model altogether. But as you can see, it actually fits this kind of architecture very nicely. You don't have one big database with tons of tables that you have to constantly keep in sync. You have different systems that they cooperate and they end up creating read models that make the access very, very fast.
Very well. On that note, I think this is the last question we can take because we're out of time. We'd like to thank all of you who have been watching our presentation, who are going to continue with the PNP Global Online Symposium. Thank you for your questions. I know there are more. We'll look through the tweet event stream and we'll act on those. You can also reach us through the website that I posted here. I also want to take a moment and thank the group of people who are participating in our advisory. They are investing a lot of time in making sure that this project is successful and that whatever we produce embodies the collective body of knowledge and not just one small team at Microsoft. So thank you very much for that.
Thank you.